Welcome to the Explainer. Today, we're unpacking some incredibly dense, honestly paradigm-shifting research on the future of large language model optimization. We're talking about the raw mechanics of how artificial intelligence actually processes information, the hard physical limits of our current hardware, and how a totally radical mathematical redesign might just pave the way for something called sovereign compute. If you follow AI scaling, you already know about the massive energy costs we're facing. So today, we're looking at how the architecture itself is being rewritten from the ground up to solve that.
Consider this for a second. What actually happens when AI literally runs out of physical energy to compute? Right now, massive AI models are slamming into what engineers call the memory wall. As these context windows grow to millions of tokens, the thermodynamic cost, the literal physical energy required to move and calculate all that data, is just becoming completely unsustainable. We are brushing right up against the hard limits of physics. Okay, let's dive into this. Here is our roadmap. We'll start with the memory and trig walls, explore the mathematical leap of side and normalization, tackle the infinite context challenge, unpack the orbital wall and metabolic dithering, and finally, look at what this all means for a sovereign AI future.
Section 1, the memory and trig walls. To really understand these breakthroughs, we have to look at the baseline established by Google's TurboQuant. Now, TurboQuant was brilliant. It shrank data by mapping vectors into polar coordinates. And here's the catch, it relied on angular transcendental math. Think of it like a continuous infinity loop. This kind of slippery, continuous math requires a ton of energy to compute. Side normalization, on the other hand, proposes a deterministic evolution. It moves us from those continuous, heavy angles to rational, discrete, low-energy staircase steps. It's basically a complete rewrite of the underlying math of AI reasoning. The core of this headache is what's known as the trig wall. See, when AI uses Polar coordinates, it relies on sines and cosines. That is transcendental math. And the big issue? Transcendental math is computationally exhausting. It wastes energy, and honestly worse than that, it creates an irrational continuum. Over billions of calculations, you get this structural data drift. The AI's precision literally degrades over time because it's trying to calculate these smooth, continuous curves on digital binary hardware. It's just a bad fit.
Section 2, Evolution, Side A, Normalization. Now, what's really interesting about this slide is how we actually fix that geometric gunk. Check out the Cayley-Ferry Bridge. Instead of relying on a continuous radius that forces all that heavy math, side normalization anchors the system to a fixed transverse component, that top block where a equals 1. What this does is it locks the entire grid into a rational, integer-based lattice using the Pythagorean remainder. To put it simply, instead of doing exhausting math to estimate a curve, the AI just perfectly clicks through a predetermined geometric grid. We transition from estimating slippery curves to mathematically certain, discrete steps.
And why does that geometric shift matter so much? Because of this exact number, 0.05 picojoules. By moving away from complex transcendental scoring to a native, discrete bit shift on that rational lattice, the energy needed per scoring operation plummets to 0.05 picojoules. That is a staggering 74 times reduction in energy compared to standard floating point math. It fundamentally lowers the metabolic floor of AI attention mechanisms. It's a real game changer.
Section 3, the Infinite Context Challenge. But energy per operation is really only half the battle. How do you actually process entire libraries of books in a single prompt without melting the server? Well, the current baseline for this is subq.ai. Now, subq did something incredible. It broke the massive computational tax of traditional attention, enabling functional long context of over 12 million tokens. And it did this using statistical hashing. Basically, it's guessing which tokens are most important, so the AI doesn't have to read absolutely everything perfectly. But it has a fatal flaw, stochastic data loss. Because it relies on statistical guessing, some information is inherently, permanently lost in the process.
Section 4, Evolution, the orbital wall.
To achieve true, high-fidelity, infinite context, guessing just isn't going to cut it anymore. That's where the source documents introduce the orbital wall. This framework completely abandons statistical guessing. Instead, it replaces those statistical masks with deterministic Turing cell boundaries on a discrete plane, meaning it assigns every single piece of data a specific, hard-coded locational address on a geometric spiral. Relevance isn't guessed, it's structurally determined by exactly where it physically sits on the grid. It trades statistical probability for absolute geometric certainty, paving the way for perfectly lossless, infinite context. And this brilliantly illustrates the concept. You're looking at a Cartesian to octagon mapping.
It's a symmetric diamond tile spiral, and those colors represent a 16-phase discrete sequence that forms an octagonal boundary. This super-dense geometry ensures that as the AI searches through massive amounts of context, it never drifts. Every coordinate is mathematically locked tightly in place, securing the data perfectly without any of that statistical decay we see in legacy models.
Section 5, Synthesis, Metabolic, Dithering. So how do we actually synthesize all these hardware optimizations together? The answer is metabolic dithering. Look, when you compress data this tightly, you're always going to have a microscopic rounding residual, like a tiny, tiny error. But instead of just throwing that error away, which is what actually causes drift, metabolic dithering dynamically distributes it across a spatial and temporal threshold using something called Pythagorean packing. Think of it like neatly packing away your spare change, so absolutely none of it is ever wasted. It acts as a resonant key that keeps the whole shebang running flawlessly on extremely light hardware. Let's move to and see how this builds into the final hardware reality. Check out this energy breakdown. A standard FP16 multiplication, that costs 3.7 picojoules. In INT8 addition, drops to 0.1. But our SIDA reciprocal shift, just 0.05 picojoules. This perfectly definitively proves how replacing power-heavy spatial approximations with discrete SIDA bit shifts fundamentally alters the physical power requirements of AI. It bypasses the heaviest hardware demands entirely.
Section 6, the sovereign AI future. Which brings us to the ultimate philosophical payoff. What do all these deterministic upgrades actually enable in the real world? It's really about changing who controls the compute. The source documents lay out this really interesting impartial comparison. On one side, you have Royalist AI. Think centralized intelligence, massive cloud mainframes controlled by huge tech entities operating as black boxes with unidirectional telemetry. On the other side, enabled by the extreme efficiency we just talked about, is Republican AI. This is agentic independence, where the AI runs entirely on local air-gapped compute, offering symmetric transparency directly back to you, the user. So the crucial point is captured perfectly in this quote directly from the text. The only Republican defense is the arming of the citizen with local symmetric compute. By dropping the energy and memory requirements to such an incredibly low floor using SIDA normalization and the orbital wall, high-fidelity, infinite context AI no longer requires a billion-dollar data center. It can actually be run efficiently and completely privately right in the hands of the individual user.
I want to leave you with this final provocative thought. If ultimate computational efficiency unlocks total data sovereignty, how will local air-gapped AI reshape your relationship with technology? When the smartest intelligence on Earth doesn't live in the cloud, but securely on your own local device, the entire power dynamic shifts. Thanks for joining me on this deep dive. Keep questioning the architecture, and I'll see you on the next explainer.